So the homework from last night, number 1A is mu of x bar equals mu equals 14,000 miles. Part B says, is it possible to calculate the standard deviation of x bar? Well, there's only one thing we ever have to check to be able to calculate standard deviation of a sampling distribution, and that's my what condition? 10% condition. Well, my lowercase n here is what? 12, so 12 times 10 is 120. So we would need to say that there are at least 120 what? This one's kind of wordy, and this is kind of particular. It's really that the cars that this particular service department or large auto dealership has on record is your population. So you could say there are at least 120 of those, or assuming there are at least 120 of those. And then sigma of x bar equals sigma over square root n. So that's 4,000 over square root 12, and it ends up giving you about 1,154.7005. Do you know the approximate shape of the sampling distribution of x bar? What did it tell us about the original population distribution? It was right skewed. So the only way that our graph, let me think about this. I'm not drawing out anything special, but I'm just drawing this out like as a thought process. So the population distribution for right now either is normal or something that's not normal. So if it is normal, what do I know about the shape of the sampling distribution of x bar?
Approximately.
So did we go down that path? No. So we went down this one, so it was right skewed. So now that we have gone down this path, I basically have two options. One of them is, what am I checking here to know which direction to go? What's my second thing I check if it's not normal?
N is greater than 30.
So my options are n is greater than or equal to 30 or n is less than 30. If n is greater than or equal to 30, my sampling distribution of x bar has what shape? What if it goes down this path?
Right skewed.
And so I'm writing this one generic, so same as population, specific to this problem would still be right skewed. So that graph isn't really helpful to draw as a graph, it's just making sure I understand that thought process there. But, so if it was normal, we wouldn't need to check the central limit theorem to making sure our n was at least 30. All right, so with this one, what is the approximate shape of the graph? Right skewed. Why? Because it wasn't normal and central limit theorem did not apply. So the idea of talking through that graph is the answer, but you don't need to write it out like that, especially. Like I would say something like the population distribution was right skewed, our sample size wasn't big enough for central limit theorem, so it follows the shape of the population distribution. Would have been a good explanation. Questions on that? Number 2, I got most of the way through in the video if you watched it. Watching some of your, or seeing some of your homework answers is disturbing. In the fact that I gave you half of that answer, and some people, like, their answer is like 3 lines. And I gave you about 12 in the part of the answer that I gave online. This is a 4-step process, so you have to answer with a 4-step process. So from now on, if I tell you explicitly that it's a 4-step process like I did yesterday and you don't do it, I'm not going to give you any credit for it. So 2B, I think I got through most of do. I don't remember where I stopped in the video. We got to the point where Z, that one I'm just gonna talk through. Z is negative 2.77. Did I even get that far? Okay. And then we get an area of, that might be where I stopped. I got all the way through. So I just didn't do conclude. Okay. So in conclude, it would be if we what? If we were to randomly select how many? Three what? Newborn babies in the U.S. or newborn children in the U.S. because it said differently in different parts. When U equals 7, then the probability that. Okay, now I want to be very clear with this part. This part should not be an issue. If you have your sheet in front of you, look at it. If I'm looking at 3C, the end of it literally, or all 3C says is find the probability that the mean weight of the 4 candy bars is less than 7.85 ounces. And that's usually how a question is going to be asked. That word for word is what you put in, find the probability that. So you literally write word for word what it says. So it says then the probability that, and you should have word for word, the mean weight of the 4 candy bars is less than 7.85 ounces is, and then whatever the answer was. I don't remember, I didn't write that part down. But I gave y'all that and see. So don't get confused on that last part to write. That should be word for word from the problem. Questions? All right, so let's do 3 together, and I'll actually write it out and make sure you're all doing it right. So, and I guess this is another thing that I shouldn't have to say. If I'm going over this answer and you have stuff written down in front of you and you don't have some of this on your paper, I would probably write it down. So state the distribution of actual weights of 8-ounce candy bars produced by a certain machine with is normal with a mean of 8.1 ounces, standard deviation of 0.1 ounces. That part is going to be confusing to some people for one reason. It's called an 8-ounce candy bar, but they're not actually 8 ounces. So 8 ounces is used for nothing other than a description. It gave us mean, or it gave us normal, and it gave us mu and sigma. So you should have written those as you went along. Company managers do not want the weight of the chocolate bar to fall below 7.85 ounces for fear that customers will complain. Well, that's going to be the part that we're answering down in C. So state, we need to start by defining our population. And who's our population? What is our population? And this is going to be super picky. Technically, it's all the 8-ounce ones. And I'm going to go word for word what it says. 8-ounce chocolate bars produced by this machine or certain machine. Some of you are going to write a certain machine, that's on there. My next thing is to define my sample. What is my sample going to be in this one? And it goes back and forth between candy and chocolate, doesn't it? I don't love that. So I was so specific here that I can just say the ones that were selected. I don't have to go back and write all of this again because I'm stating that that is coming from that. My next thing I need to do is what? So again, I've already defined my population, so I don't have to re-specify that here. This has to start with mean, and it's the mean what? I would probably go into a little bit of that. Because without it, to me, it doesn't make sense. If you just write mean weight, I would count off. Because mean weight of what? If you say candy bar there, that's fine. Mean weight of candy bar, technically it's of the 8-ounce candy bar, chocolate bar, but you need to say mean weight of the candy bar. And then the other thing is what I'm going to find in this problem. So this is P parentheses, what? I keep wanting to do this with a certain problem, and I just haven't had one that we don't keep stopping during. So I'm going to make a big point about this number and where it is in the rest of the problem. But just remember that that's the only reason I'm highlighting that right now. All right, so plan. First thing I check is what? Which is capital N is, and I know my lowercase n, which is 4, right? So capital N is greater than or equal to 40. I need to write what? And some of this stuff that I'm going to write is going to be like, if people are lost when they're watching this video, it should help make connections of where they're coming from. So what up here am I writing here? Population. So I just rewrote that part right here. The 40 comes directly from there. Just making sure everybody's getting those connections. So we're good. Next condition is normal. What do I need to do there? And does it? So tell me what to write. So it is stated that the population distribution is normal. So you can use normal approximation. Now that you've seen some problems, y'all have asked good questions as we've gone, but it's kind of been like, you'll get it. Like number 1 didn't meet one of the conditions. So it didn't ask you to solve the whole problem. It'll ask you like a piece by piece problem like that. And be like, why didn't I? It's not going to have you try to do a 4-step process and just stop in the middle of it. So do, what are some numbers that this problem gave us? Which was, what else? Which is, and, which was, and these should have been things that you marked as you read the problem. So mu of x bar equals what? Which equals, and then sigma of x bar equals what in symbols?
Sigma over square root 1.
What is sigma? Number? What is n?
4.
So that gives us,
0.05.
what do I need to write there?
Contrast. Or 10%.
So I've already checked it, but I'm just making the connection to show this is where, what I needed to check the 10% condition for. So at that point, I'm writing less than. Okay, so this is where I wanted to make that connection. What the problem asked me about, I don't write anywhere until I get back to writing this exact same thing. I don't use it for any of plan or normal, or any of my plans. I don't use it for any of my equations up here. I don't use it at all until I get to where I'm finding my z. So I do have people that get confused with that, so make sure that you understand that part. So now, that number that I used for the first time goes here and not the second one. So then I drop this number, so minus 8.1 divided by 0.05, and you get what here?
-5.
Our sheet in front of you, the green sheet, goes from here to here. What is the area at this number? So I'm getting a number that's actually like here. So what's that area going to be?
Close to 0.
It's definitely going to be less than that. It's not going to be much. It's close to 0. So if we get something that's really far away like that, some people are going to say area of almost 0, or you can write less than this or less than 1. And either one of those is technically fine. I'm shading to the left, so you just need to show that it's like way over here. And then you could say area, and you can literally write close to 0. Close to 0, less than 0.0002, anything like that. So we can leave our answer as close to 0. This kind of thing would really happen if we actually did certain things that would ended up biased, like the whole GPA of AP Stat versus GPA of all seniors. You would probably get a z-score farther away than 5. I would hope. So, because it's shaded to the left, so I don't have to do anything with that. So my conclude is if what? How many? What it was, a machine? What else? Oh, it's done that before. Just try to think back up. I need to get another check over there. Then so what should I write starting right there? Looking at your paper. The next part should word for word be what?
But there'll be more.
That the mean of the 4 candy bars is less than 7.85 ounces. So we're literally going word for word that part. And then would be is close to 0. Questions?